All right, let me walk you through these questions that you need to know. What is the missing angle of a triangle? Well, the three angles of the triangle will add up to equal 180 degrees. So 65 plus 57 plus what equals 180? Use a little bit of subtraction, you get 58 degrees. The classification, what type of triangle is it? Well, what is the smallest angle in this? It's an acute angle that makes this an acute triangle. Number two, 40 plus, remember that marking means 90, 40 plus 90 plus something equals 180. That's 50 is what's missing. Because the biggest angle is a 90-degree angle, this makes this a right triangle. The missing angle number three is 30 degrees. 20 degrees plus 130 degrees plus 30 equals 180. Because the biggest angle is 130 degrees, that's an obtuse triangle. Number 4 and 5, those quadrilaterals, the sum of the angles of the quadrilaterals is 360 degrees. So add all these angles together, the one that's missing is going to be 80. On number 5, add all those together, the one that's missing is 60 to get 360. I've told you that you're not going to have to do this circle stuff on the test, but if anybody did go through this is what you would need to know. It'd be pretty exciting if you got any of those right, but for the moment, we're going to skip right through it because this is not going to be on your test. However, these concepts matter to us. 2 points contain exactly how many lines? 1. If you got 2 points, you can make a line. 3 points are what? Always, sometimes, or never coplanar. You can either make a line or you can make a triangle. Either way, they are in a plane together. No matter where those 3 points are, they're always coplanar. 3 points are always, sometimes, or never collinear. Well, look what I just did. They are collinear. 3 points here are not, so they're sometimes collinear. Draw the ways that a line and a plane intersect. I will not ask you to do this on the test, but they're either parallel, it passes through and it intersects at exactly 1 point, or the line is in the plane. You need to recognize these things, but you're not going to have to draw them on your test. Blank is the measure of each angle of a square. The answer is, oh, yeah, I was explaining what I just did. That's 90 degrees. Blank is the measure of each angle of an equilateral triangle, 60 degrees. These three definitions that we saw on the last exercise, an angle bisector creates two congruent angles. A segment bisector creates a midpoint creates two congruent segments. Number 16, if you didn't draw it, you should have. If K is the midpoint of segment TO, TK is 6x plus 9. KO is 10x minus 7. Because it's a midpoint, those guys are equal. Solve. I got 4. Plug it in, and you get those other answers. Okay? Here's a bit of a puzzle. Because I'm not there and stuff like this, this is also not going to be on your test next class. However, hopefully you figure this out. If AC is congruent with CE and B is a midpoint, that makes these congruent. Then it tells us that CD is equal to 2 and AB is equal to 3. Now, this midpoint part means that if this was 3, if AB is 3, well, so is BC. That midpoint makes it the same. Well, that makes this whole thing AC equals 3. 3 plus 3 is 6. Well, then it told us these were congruent, so that was also 6. So what's missing? The 4. It's kind of a puzzle piece. If that's confusing to you, don't worry about it much. Ray CA or ray CB are opposite rays. Remember opposite rays? Ray CD starts here at C, travels this direction through D, also through E. The opposite ray will start at C and travel through B or through A. So CA and CB are the answers. On the other side of the page, this is a diagram made for the segment addition postulate. AB plus BC equals AC. So that's x plus x minus 6 equals 18. When you solve, you get 12. On number 20, what is the vertex of angle 1? That's point A. What is the vertex of angle DAC? You actually don't need the diagram to answer that question because the letter in the middle is your vertex. It's also in the diagram, but still. Blank and blanks are other names for angle BAC. You can always switch the letters around, so angle ACB. And then angle ACB is this guy over here. That 3 over there helps us name it as well. Adjacent, next to angle BCA. Angle BCA is this angle right here. The angle that's next to it. It's also going to start at C and go towards A. So it's going to be ACD or DCA is adjacent. If AC bisects angle BCD, then those are going to be two congruent angles. That's kind of the process we've been working on a little bit. And then this is an angle addition postulate question in here. Part plus part equals a whole. Angle 1 is a part, angle 6 is a part, angle BAD is the whole. So we get to add those suckers together and get n is equal to 8. Once I know that n equals 8, I can plug this stuff in and get these answers. And indeed, they add up and equal. Here is the angle bisector question. In this case, it gives us that PQS is 8W plus 12, and then PQR is 5W minus 3. PQS is the whole, PQR is the part. So this equation here is incorrect. I need to have two of those. So I'm going to double the 5W minus 3, or add two of those together. Whatever one is, the other one is as well. Once you get the W is equal to 9 from the equation, you can plug them in to fill in whatever other answers you need. Get up. And then we got these questions. Blank is the intersection of these. Those two, the O and the L are in the two planes, and then hopefully you can also see it from the diagram here. This O and L are the shared points. So line or segment OL I would accept as well. Blank is the intersection of NMIJ and line HM. Well, the point that is shared is M. They intersected M. And then JM is the intersection of NMIJ and JM. Line JM is in the plane. So the intersection, I got cut off there. Yeah, JM is the intersection. Hopefully that made some sense. All right, love you, bye.